Good morning, students. I hope you all are good. I'm also okay. Chapter 3, current electricity. Yes. Today's topic is limitations of Ohm's law. First of all, what is Ohm's law? Yes, we know Ohm's law. That is V is proportional to I. Okay. Under definite situation, V is proportional to I. Okay, and that definite situation is constant temperature. Okay, and yes, what is I versus V graph? A straight line. Okay, so for Ohm's law, V is proportional to I. As V increases, I increases. Graph is also linear. And such devices are called ohmic devices. But there are many other devices which do not obey this law. Okay, for example, see here we have to discuss some points. Limitations of Ohm's law. The deviations are broadly one or more of the following. First, V is to be proportional to I. It means V and I are not directly proportional to each other. Yes, for ohmic devices. Ohmic devices means in which Ohm's law is obeyed. For such V versus I graph. Okay, for ohmic devices which obey Ohm's law, V is proportional to I. So for such devices, IV graph is a straight line. Yes, you know it. But in future we will study some another devices. For example, diode. In case of diode, V versus I graph is not a straight line, but it is like this. Okay, in case of diode, so see here in this case, V is not proportional to I. Proportionality, okay, is not obeyed. So here V is not proportional to I. So that is first point. Okay, V and I, they are not proportional to each other. So that is first limitation. The devices in which V and I, they are not proportional to each other, in which Ohm's law is not obeyed. Now second point, see here. The relation between V and I depends on sign of V. It means if I is the current for a certain voltage, then reversing the direction of V, keeping its value fixed, does not produce a current of the same magnitude I in the opposite direction. Now what is meaning of this? See, if we take a conductor, metal, in case, okay, obeying Ohm's law, then if it is one conductor, it is connected with battery like this. Okay, it is positive terminal, it is negative terminal. So current is flowing in this direction. I clear about this. Okay. Now if I reverse direction of V. Okay, direction of V. It means like this. Now see, polarity is changed. Plus minus. Now here it is plus and minus. So direction of current is like this. Clear about this? Okay, here direction of V is changed, the direction of current is also changed. For conductors obeying Ohm's law, if you find relation between V and I, for conductors obeying Ohm's law, if you find relation between V and I in these two cases, it will be like this: V versus I, a straight line. Clear about this? But in case of diode, okay, see here it is graph. It is V, I, and here is minus V. If voltage supply V is positive, for example, like this case, okay, positive and negative, then variation of current with voltage is like this. Now if I reverse the direction of V, keeping its value fixed, then it does not produce a current of same magnitude in opposite direction. See, I am reversing its direction. Now means V becomes negative. So its value does not become same. That graph is like this. Okay, so see, this relation and this relation, they are not same. They are not same. Okay, now what about this relation? We will discuss in chapter number 14 in semiconductors. In semiconductor, what is diode and how to form these graphs of diode, that we will study in chapter number 14. Right now you have to remember, okay, yes, in this case, if we change polarity of battery, if we reverse direction of voltage, then same amount of current is not produced. Same amount of current is not produced. In this case, current of milliampere is formed. In this case, current of microampere is formed. Okay, that we will study in chapter number 14. Now last, third point. The relation between I and V is not unique. What is meaning of unique? For one value of voltage, there is only one value of current, or for one value of current, there is only one value of voltage. Okay, but in some devices, there is more than one value of V for the current. See here in this figure, here it is. See, for this value of current, only one value of voltage. For this value of current, only one value of voltage. Yes or no? So 1 to 1, unique relation. Okay, but in some cases, in some devices, the IV graph is like this. IV graph is like this. For example, it is V, it is I. That IV graph, it is like this. So what is meaning of this? See, for this value of current, you will have two value of voltage. You will have two value of voltage. Clear about this? There is more than one value of V for the same current. Clear about this? So see, it is third limitation of Ohm's law. Clear about this? Okay, what is Ohm's law? First of all, you have to clear what is Ohm's law. Okay, then after you can understand these limitations. Clear about this? Pause your video and write down from bottom. Okay students, now next topic is temperature depends of resistivity. Temperature dependence of resistivity. Yes, resistivity depends on two things. Okay, as we have discussed. Temperature and material. As temperature changes, resistivity changes. As material is changed, resistivity is changed. Okay, now here, see, over a limited range of temperatures that is not too large, the resistivity of metallic conductors is given by rho T is equal to rho 0, 1 plus alpha T minus T 0. Yes, you have to accept this equation. Okay, rho T is equal to rho 0, 1 plus alpha T minus T 0. Now understand this equation. See, what is rho T? Rho T is resistivity at temperature T. At a temperature T, it is temperature T. So rho T is resistivity at temperature T. Clear about this? Okay. What is rho 0? Similar. Rho 0 is resistivity at temperature T0. Resistivity at temperature T0. So it is resistivity. It is resistivity at temperature T0. Clear about this? So yes, now you understand T and T0, they are temperature, in which T0 is called reference temperature. In which T0 is called reference temperature. Yes, students, see, one note. This reference temperature, you will be given in data, or sometimes we have to assume. Sometimes we have to assume this reference temperature. We will solve some questions based on this theory, so you will understand how to assume this reference temperature. Now, rho T, resistivity at temperature T, rho 0, resistivity at temperature T0. T0 is reference temperature. What about alpha? Alpha is called temperature coefficient of resistivity. It is called temperature coefficient of resistivity. It is called temperature coefficient of resistivity, and it depends on material. Yes, in your textbook you are given one table. In your textbook you are given one table for different materials, resistivity, okay, and its value, temperature coefficient of resistivity. Now see, temperature coefficient of resistivity alpha is in multiplication with the temperature difference. So what is unit of alpha? Unit of alpha is degree Celsius inverse or Kelvin inverse, or it is Kelvin inverse. So remember this thing, okay? You have to remember this equation, okay? Last year in board exam, one question was asked from this equation, clear? Now, resistivity depends on temperature. So for different material, now we will see variation of resistivity with temperature. Okay, for conductors, for alloys, and for semiconductors. See students, we are doing hard work for you. So now it's your responsibility to do hard work for yourself. Study, and study. Okay, see, resistivity versus temperature graph, rotary graph. First graph for conductor. Okay, it is resistivity and it is temperature. Okay, see graph, it is graph from experiments. Take one conductor, keep that conductor at different temperature, then with the help of this equation calculate its resistivity. So you will get one table for temperature resistivity, and from such values you can draw this graph. See here, as temperature increases, resistivity also increases, and just we have discussed in last lecture. In case of conductor, as temperature increases, resistivity increases. So here it is, temperature increases, resistivity increases, and therefore value of alpha is positive. To see this, each and every statement is one MCQ. For conductors, alpha is positive. For conductors, as temperature increases, resistivity increases. Clear about this? Now, another 3 points. See, at lower temperature, initially when temperature is lower, at lower temperature, see, graph is like this. Okay, it is a curve. So, at lower temperature, graph is non-linear. Means as temperature increases, resistivity is not proportional to it. Okay, non-linear meaning. At room temperature, the graph is linear. Linear means, yes, as temperature increases, resistivity is proportional to temperature. Okay, now for higher temperature, again graph becomes non-linear. So yes, we have to remember 3 points. At lower temperature, that is less than 50 Kelvin, graph is non-linear. At room temperature, it is linear, and at higher temperature, it is again non-linear. Clear? So it is about conductor. For alloys, for example, we have one example, nichrome. Okay, it is one type of alloy. And for these alloys, what is variation of resistivity with the temperature? Yes, you are given graph, and I have some values of temperature: 200, 400, 600. But what is value of resistivity? See, observe. It is 0. Okay, it is 1.1, it is 1.2, etc. See, if here temperature is 0, okay, and here temperature is suppose 800 at this point. At this point, resistivity is 1, and at this point, resistivity is nearly 1.2. To see, there is change in temperature 800 Kelvin, but change in resistivity is very small compared to change in temperature. It means for alloys, very weak dependence of resistivity with temperature. Clear? If you change temperature over a large range, change in resistivity is very small. Okay, so you have to remember this point. Another point, high resistivity. Yes, alloys have high value of resistivity that you can see from that table. Okay, next point, almost independent of temperature. Manganese, one alloy, for that manganese resistivity is almost independent of temperature. It means if we change temperature, resistivity does not change. If we change temperature, resistivity does not change. Last point for this alloys. See, it is 0 Kelvin temperature. Yes or no? But at this temperature, is resistivity 0? No, resistivity is not 0. Resistivity is not 0. Here it is. At 0 Kelvin temperature, resistivity is not 0. But for conductors, see, for conductors, at 0 Kelvin temperature, its resistivity is 0. Its resistivity is 0. Clear? So, how to test metal? Okay, how to identify metals? Yes, for metals, for conductors, as we decrease temperature at 0 Kelvin temperature or at 0 temperature, its resistivity will become 0. Last point, semiconductor. Yes, again we have discussed in last lecture, as temperature increases, in case of semiconductor, resistivity decreases. As temperature increases, resistivity decreases. So here value of alpha is negative because graph is in downward direction. See difference between these two graph? Graph in upward direction, temperature increases, rho increases, alpha positive. Graph in downward direction, temperature increases, rho decreases, alpha is negative. And yes, about the semiconductor we will study in chapter number 40. Clear? So it is one theory, temperature dependence of resistor. Now there is one similar equation. From this resistivity of resistance. See, what is equation? What is equation? I am writing here. Here it is. RT is equal to R0 1 plus alpha T minus T0. It is equation of resistance. Again, what to write? RT means resistance at temperature T. R0 means resistance at temperature T0, that is reference temperature. Alpha, temperature coefficient of resistivity, and T, temperature of object. T0, reference temperature. So, yes, you know this equation. From this equation, you can also write this equation of resistivity. And yes, you have to remember this equation. From this equation, we have to solve 2 examples and 1 exercise question. Okay, pause your video and write down from there. Okay, students, now we will see some questions based on resistivity and dependence of temperature on resistivity. Okay, see here, exercise 3.16. You are given 2 wires, 2 cables, one of aluminium and another of copper, of equal length, having same resistance. Your question is, which one is lighter? Again, you are given 2 wires of equal length, same resistance. Which one is lighter? That is your question. That is your question. Okay. Lighter means you have to find or you have to compare their masses. Okay. You have to compare their masses. Rho N. See students, take care of one thing. Rho means resistivity. You can also think from this unit. Rho Al means resistivity of aluminium, 2.63 into 10 raised to minus 8 ohm meter. Rho is resistivity. Rho of copper, 1.72 into 10 raised to minus ohm meter. Relative density of aluminium, Sal, is equal to 2.7, and relative density of Cu is 8.9. You have to find which one is lighter. Which one is lighter means you have to find relation between their masses. Now, how to introduce mass? Okay, see, first of all, you are given this relative density. Then how to find density? You know one equation. Relative density is equal to density of object upon density of water, Okay, so I can write this equation as S is equal to density of object, relative density of object is equal to density of object upon density of water. Clear? So therefore, rho 0, density of object is equal to specific or relative density of object into density of water. Clear about this? Then what is density of aluminium? What is density of aluminium? See here, now rho is already resistivity. Then here we will define this density, or we will write this density as D. We will write this density as D. D of object upon D of water. Okay, here also it is D of object upon D of W. D means density. Okay, then density of aluminium is equal to relative density of aluminium into density of water. Clear about this? Clear about this? Okay, here D is for density. D is for density. Okay, similarly, density of copper is equal to specific density of copper, density of water. Clear about this? Okay, now you have to find which one is lighter, means you have to take ratio of mass. Now how to introduce mass? See, you are given one condition, same resistance. So I can write same resistance like this. I can write same resistance like this. Okay, R of aluminium, R of copper. Clear about this? Okay. R is equal to rho L upon A. Rho L of aluminium upon A of aluminium. Clear about this? What is the equation of resistance? Rho L upon A. This side it is rho of Cu, length of Cu divided by cross-sectional area of Cu. Now there is no mass in this case. There is no mass in this case. And yes, you are given relation of length, but you are not given relation of cross-sectional area. You are not given relation of cross-sectional area. So here you have to neglect, or you have to eliminate. You have to eliminate cross-sectional area. How to eliminate this cross-sectional area? See, here I am multiplying this side with length and dividing with length. Right now, see, rho L squared Al upon A of aluminium, L of aluminium. Clear about this? Clear about this? Is equal to rho of Cu, L square of Cu divided by A of Cu and L of Cu. Clear? Now we know that cross-sectional area into length, cross-sectional area into length, it becomes volume. It becomes volume. Then how to write this equation? See, rho L square Al divided by volume of aluminium. Clear about this? This side it is rho Cu, L square Cu upon volume of Cu. Clear about this? Now, again it is volume. How to take mass? You know the relation. Density is equal to mass upon volume. Then volume is equal to mass upon density. Then volume is equal to mass upon density. Then now I will replace this volume. By mass upon density. Then what is equation? See, here it is rho L square Al divided by V of aluminium means mass of aluminium upon density of aluminium, means here density of aluminium. Right hand side, you do not have to think, just replace Al by Cu. Okay, so here it is rho of Cu, L square of Cu, density of Cu upon mass of Cu. Clear about this? Now see here, you are given same length, equal length. Equal length means length of aluminium, length of copper, same. So it is done. Clear? Then what remains? Mass, resistivity, density. Now take ratio mass of aluminium upon mass of copper. Mass of aluminium upon mass of copper. Here mass of aluminium comes in numerator. Okay. This term, this side, and this term, this side. Clear about this? So if you make mass of aluminium upon mass of copper, then what remains is equal to rho Al, density of Al, upon rho of Cu upon density of C. Now you are given each and every data. Density. Okay. See, we put value of density. Here you can also write this as, see, here it is rho Al. What is density of aluminium? It is SAl, density of water, divided by rho Cu, specific density of Cu, and it is the water. So cut. Okay, now put this 4 value. Okay, find what is ratio of aluminium upon MCU. Okay, and from this ratio, okay, you have to think, you have to write answer. Okay, which one is lighter? Yes, you know relations. Okay, if M1 is equal to M2, means they both are having same mass. If M1 is greater than M2, then M1 having large mass and M2 is lighter. Okay, so you understand about this relation. So find this MAl upon MCU ratio. What is your answer? From that answer, you have to write answer. Okay, which wire is lighter in comment box. Write your answer, which wire is lighter in comment box. Pause your video and write down from bottom. Okay students, now see next question, exercise 3.5. What is data? Okay, at 27 degrees Celsius, resistance of material is 100 ohm. Then at which temperature its resistance is 117 ohm. Given temperature coefficient of resistivity alpha is equal to 1.70 into 10 raised to minus 4 degrees Celsius. Now see, in such question, yes, you are given to temperature, to resistance, 1 alpha. So obviously, you know which equation you have to use. You have to use this equation. RT is equal to R0, 1 plus alpha T minus T0. Clear about this? Okay. Alpha is given. Yes, here it is. Now, how to write these 4 things, data? 27 degrees Celsius, 100. See, here you are not given any reference temperature, but you are given temperature 27 degrees Celsius. That is nothing but room temperature. Okay. So consider this room temperature as reference temperature. So I am here assuming let 27 degrees Celsius is reference temperature. Okay. Now how to write this data? See. It is reference temperature, means it is T0. At reference temperature, resistance is 100 ohm, means it is R0. This temperature T you have to find, and at this temperature you want given resistance, means it is RT. Clear about data? Now you know each and every value. What is value of RT? 117. Yes, it is 117. What is value of R0? It is 100. Okay, 1 plus what is value of alpha? 1.70 into 10 raised to minus 4. What is value of T? Question mark. And value of T0? It is 27. Clear about this? Now yes, it is mathematical step. You have to find its answer. Clear? From this, you have to solve this question. Okay, next question. See, exercise 3.6. One conductor carrying current having length 15 meter means L is equal to 15 meter. Okay. Cross sectional area means A is equal to 6 into 10 raised to minus 7 meter square. Resistance 5 ohm means R is equal to 5 ohm. Resistivity question mark rho is equal to C. Easiest question. Yes, you know which equation you have to use. R is equal to rho L upon A. Okay, make rho as subject, then rho is equal to, it is RA upon L. Each and every value you are given. Okay, calculate, use calculator and solve this. Clear? Next question. See, one material is given. For the material, resistance is 2.1 ohm when temperature is 27.5 degrees Celsius. Resistance is 2.7 ohm when temperature is 100 degrees Celsius. You have to find what is temperature coefficient of resistivity. Again, if you observe data, again you have to use this equation. RT is equal to R0 1 plus alpha T minus T0. Yes or no? Yes. You have to find alpha. So what about another four things? RT, R0, T and T0. Yes, you can easily identify. Assume this 27.5 degrees Celsius, that is room temperature at reference temperature. So it is T0. It is T0. Then it is R0. Clear about this? If it is temperature T, then it is resistance RT. Clear about this? Now put value in this equation and find what is value of alpha. What is value of alpha? Clear about this? Now next question. See, exercise 3.8. Exercise 3.8. Case 1. You are given one conductor which is connected to a 230 volt supply. Current flowing is I is equal to 3.2 ampere. Initially it is at room temperature. Now, as current is flowing from it, its temperature is changed. And in second condition, again the conductor is connected to same 230 volt supply, but current becomes 2.8 ampere. Okay. Room temperature is 27 degrees Celsius. Find steady temperature of heating element. In this case, what is temperature? Okay, alpha is given. What is data? Again, initially material is at room temperature, connected to 230 volt supply. Current flowing from it 3.2 ampere. At some another temperature, again same voltage, but current is I is equal to 2.8 ampere. Okay. Find steady temperature of heating element. In case 2, what is temperature? Alpha is given. Now see, you know which equation you have to use. This equation. Okay, RT is equal to R0 1 plus alpha T minus T0. What about data? See, here it is. It is initial condition. In this case, from V and I can find resistance. From V and I can find resistance. How to find resistance? Reference temperature. You are taking reference temperature T0 is equal to 27 degrees Celsius. Then at this temperature resistance is indicated by R0. And R0 is equal to it is V upon I. R is equal to it is V upon I. V it is 230 volt and I it is 3.2. Yes, you can find what is value of R0. Similarly, at another temperature, yes, you know what is value of V and I. So from this you can find what is RT. RT is equal to it is V upon I. It is 230 volt divided by current is 2.8 ampere. So yes, you can find. So see, from this you will get value of R0. From this you will get value of RT. Now put each and every value in this equation. You know RT, you know R0, you are given alpha, you know 27 degrees Celsius. Yes, you can easily find what is value of temperature. Clear? So yes, 1, 2, 3, 4 questions you have to solve. Okay, and send right answer on my number. Pause your video and write down from bottom. Sorry. Example 3.3. See, what is given? One electric toaster at room temperature 27 degrees Celsius. Resistance of coil of toaster is 75.3 ohm. Clear? You are given one electric toaster at room temperature, that is 27 degrees Celsius. Its resistance is 75.3 ohm. Now, when toaster is connected with supply of V is equal to 230 volt, current flowing from toaster is 2.68 ampere. So yes, its temperature you have to find. Okay, what is temperature of toaster now? You are given alpha is equal to 1.70 into 10 raised to minus 4 degrees Celsius. Yes, at this temperature you are given resistance. So assume it is T0, reference temperature. So it is value of R0. Clear about this? You have to find temperature T is equal to question mark. And at this temperature, what is resistance? You can find from this. RT is equal to, it is V upon I, means 230 divided by, it is 2.68. So you will get what is value of RT. Clear about? Now you have R0, T0, RT, T you have to find, and I is given. So which equation you have to use? RT is equal to R0 1 plus alpha T minus T0. You have to use this equation. Clear? RT, yes, you will calculate R0 given 1, yes you know, alpha is given, T you have to find, and T0 is given. Clear about this? So this question is again as your homework. You have to calculate this term and send the solution. Next question, example 3.4, and yes, it is one IMP question, and yes, it is one IMP question. Okay, what is given? You are given a platinum wire resistance, a platinum wire resistance. When this platinum wire resistance is at ice point, means temperature, ice point, it is at ice point, that is resistance is 5 ohm. When it is at steam point, its resistance is 5.23 ohm. Your question is, when it is inserted in hot bath, its resistance is this. Then calculate temperature of hot bath. Now see how to write this data. How to write this data? See here, ice point means temperature 0 degrees Celsius. Yes or no? Steam point means temperature 100 degrees Celsius. And you have to find what is temperature of hot bath. Means I am making this T as question mark. I am making this T as question mark. Now see, you are given total 3 temperature. Out of these 3, 2 are known, 1 is unknown. I am taking this ice point as reference temperature. I am taking this ice point as reference temperature. Okay, so I can write it is T0 is equal to 0 degrees Celsius. Then it is R0 5 ohm. I am taking this steam point at T1 temperature. Then it is value of R1. Clear about this? If hot bath its temperature is T2, then resistance when temperature is T2 is R2. So clear how to write data? Take ice point as reference temperature. So T0 is equal to 0 degrees Celsius. At this temperature, resistance is R0 5 ohm. At steam point, that is T1 is equal to 100 degrees Celsius. Resistance R1, it is 5.23 ohm. Hot bath, T2, temperature, resistance is R2. Now which equation you have to use? Yes, you have to use this equation. RT is equal to R0 1 plus alpha T minus T0. Okay. Now I can write this equation as R1 is equal to R0 1 plus alpha T1 minus T0. Clear about this? T1 minus T0. Okay, R1 is equal to R0 1 plus alpha T1 minus T0. Now if I simplify this equation, okay, I can write like this. R1 is equal to R0. Multiply this R0 with 1, it is R0. Plus it is R0 alpha T1 minus T0. Clear about this? Now R1 minus R0 is equal to R0 alpha T1 minus T0. Clear? It is equation number 1. It is equation number 1. Now you can also write equation of R2. R2 is equal to R0 1 plus alpha T2 minus T0. So R2 is equal to R0 plus R0 alpha T2 minus T0. I am writing equation directly, and you also have to write direct equation. Okay, R2 minus R0 is equal to R0 alpha T2 minus T0. Equation number, clear about this? Now take ratio of this to equation. See, R1 minus R0 upon R2 minus R0 is equal to R0 alpha T1 minus T0 divided by R0 alpha T2 minus T0. So this R0 alpha cut. Clear about this? Now R1 minus R0 upon R2 minus R0 is equal to T1 minus T0 upon T2 minus T0. See here R1, here it is given. You are given value of R1. R0, yes, you are given value of R0. R2, you are given value of R2. Again R0. T1, here it is 100 degrees Celsius. Yes, you are given. T0, 0 degrees Celsius. Yes, you are given. T0 again given. You have to find what is value of T2. Put each and every value and calculate. You will get your answer. Pause your video and write down from board.